All right. So today we're going to be talking about cross-site scripting. And without any further ado, let's just go ahead and jump into it. So we'll just talk about what it is. And the way that I'd like to remember it, or at least think of it, is that it's injecting JavaScript into a browser. And the reason cross-site scripting is like one of the big bad in the OWASP top 10 and is so prevalent is because, well, tons of websites take user input and tons of websites use JavaScript, and the, amount of things that we can do with cross-site scripting, or, the JavaScript that we're embedding in that page is pretty wide, right? Like we can impersonate users. We could do basically anything a normal user can, read their data. You can capture login credentials, by looking at the password manager in that browser maybe, or other files that the browser might have access to, or things that they might have cached. You might be able to deface the website in some stored cross-site scripting examples, or you're going to add some kind of malicious functionality to a website that makes it worse for users to, be interacting with. So, but aside from that, there's kind of, because of how broad this is, there's different types of cross-site scripting that we're going to use to differentiate them. So we'll start with reflected. Reflected cross-site scripting is when an application receives data and it's reflected in an immediate and kind of unsafe way. So sites that use like search functions are good examples of this. And I've got a screenshot here where you can see like they escape what looks like either some other kind of tag that they're in. They declare image source X, and then on error will trigger alert 123, and then that JavaScript alert 123 gets executed because there is no image source called X, and it pops up. So, I mean, you might think this is outlandish, but, like this is Microsoft Bing, like it's a, huge company on, Microsoft Edge is the browser used here. So it's clearly not like super dated like the next example is going to be, but it's just worth keeping in mind that, these things are, common. People submit bug bounties on these all the time. You should definitely add this to your kind of roster of things to look for. The next one, and it's kind of easy to mix up with reflected, especially when you're first learning it, is stored cross-site scripting. So it's still when an application receives data and includes it in a response, but it's more of the fact that that response is going to be persistent to an extent. So this example that we've got on the screen here is from, I think, 2010. Justin Bieber music video had a comment that somebody used as a proof of concept in the YouTube comment functionality of stored cross-site scripting. So whenever anybody visited the page and they loaded that comment, it would execute JavaScript that would open this little alert box, and it said this kind of troll type message that Justin Bieber died in a horrific car accident. Please visit the homepage. And, clearly that wouldn't happen on YouTube. Why would they, what kind of functionality would they have had that made that important? But you get the idea. If it's a comment on a web page, it's persistent to an extent. But what's more important is that, for something like reflected cross-site scripting, you might need to put your JavaScript in a URL parameter or something that the user or the victim will have to, click on at some point. But with stored cross-site scripting, you might be able to actually just send them like an internal, direct message, like if it's something like LinkedIn. And you can get stored cross-site scripting on a post on LinkedIn. You might be able to just say, hey, go check out my post. And when somebody does, you might be able to grab some of their credentials or their contacts or whatever. So various examples you could be using. Next thing we're going to talk about is going to be, and this is the final type, is DOM-based cross-site scripting. In my opinion, this is the most confusing type, but it's also, just, you got to know it. So the vocab for this is just the document object model. The best way to describe, I guess, kind of the bigger picture of what this might look like is attackers will still be executing JavaScript just by delivering payloads to, it'll be delivering a payload to some location that's propagated to a sink and then gets executed. So sinks are the locations in the document that the model or that the DOM processes input. And in order for that JavaScript to be run, that sink needs to support execution. So keep in mind that, DOM-based requests aren't persisted, and they're not really handled by the server either. They're just, functionally part of the user's browser. I know this isn't super clear at the moment. I'll try to, clear it up by talking more about like sources and sinks. So sources are JavaScript properties or functions that take user input from somewhere and then, use it with a query string, or, that might be an example of a source if it's used with a query string. And a sink is some kind of potentially dangerous function that if the attacker can control the data that's passed into it, maybe the function can do something unintended. So we'll see some examples of this. And there's a huge list of, sources and sinks to look out for that would really just turn this into a cheat sheet video. And I don't really want to turn this video into that. I want to encourage you to go try things out and test things while still kind of just guiding it along. But we'll talk about how you might find like a context, and a context is just, the location in a response where your input gets returned and whatever validation is being performed on it. So for example, right, if you are trying to find cross-site scripting in the context that your input is between HTML tags, okay, you might need to escape out of, those HTML tags and then put in your JavaScript payload here. Or, maybe you've got tag attributes. I don't have an example on screen, but like, if you're in the href attribute or something like that, you might need to use some kind of other payload to actually, get something executed. Tag attributes are a little bit different between HTML tags, are a little bit different. Inside JavaScript, you might need to just clear out of that previous script or use part of the script's functionality to execute whatever JavaScript you're trying to get past. A lot of these things can be really contextual, which is why finding the context is important. Because if you can't really find the context, you might just be throwing payloads at it forever until you magically hit the right one. But that's not really efficient, and it's not really a good way to use your resources either, because you're just making it take longer than it might have to take. But let's talk about what we might actually do. Some of the exploits that I've been showing off on here aren't really all that reasonable, right? Like it's oh, okay, like alert 1, not really sure what that does for me. Showing a funny troll message about Justin Bieber, like whatever, not really something that's going to help an attacker that you should really be worried about. However, because JavaScript, you can do basically anything with the browser. There's plenty of stuff an attacker can do. We can steal cookies. Now the problem with stealing cookies is there's some limitations, right? Like a user needs to be logged in for you to actually get those somehow. Or they at least need to have an active session that you can replay. And because of that, right, sessions might be locked after a certain amount of time, or they might just expire. Sites might use HTTP only to hide cookies from other domains. So if you try to redirect, some kind of traffic to your domain, or, execute JavaScript from your domain and send it back, it might be kind of an issue because you're not going to see it. Sessions also might get locked by like an IP address, and you might just be SOL for that. That's why like something like stealing passwords might be a little bit more, what's the word? Like it might be more worth taking advantage of, because you don't need to deal with a lot of those shortcomings of the cookie stealing stuff, right? You don't need to steal a password in plain text or something as it's passing through. You might be able to just use your cross-site scripting and your JavaScript to read something from their password manager, be that the password manager that's built into the browser, or if you assume that they're using, some other common password manager like LastPass or Bitwarden, you might be able to use JavaScript to interact with that. And then, cross-site request forgery, kind of similar, really depends on the context of, what you're trying to do and what the application is capable of doing. But, if, there's a website that doesn't require you to enter a password to reset an email address, we might be able to get another user to set their email to something we control, if we're able to, get, internal requests to be sent, especially given, cross-site request forgery, we can imitate any other user, so we could, do whatever we want really, as long as it falls under that category. And of course, there's protections for this stuff. Content security policy is one of many protections, but in my opinion, it's like one of the most like blanket over the fire kind of like protections, right? So it's designed to mitigate cross-site scripting, and it's by restricting what scripts and images a page is allowed to load, and restricting whether or not a page can be framed. Don't really worry about the frame stuff right now. We'll talk about that more when we go over clickjacking attacks. But loading or restricting scripts and images to be loaded by a page are the big thing here. So you can see an error here that might show up in your browser's console. Refuse to load the script evil.com/eviljs because it violates the content security policy directive. And here's the interesting thing: you have to declare a directive for your content security policy. Script source self means that it will only allow scripts that are coming from the domain that is being accessed. In this case, you can specify a domain. So this, screenshot here is showing, no scripts that aren't coming from or a script that is not coming from apis.google.com is not going to run, period. So it works a lot of the time, but there are some complications with it. Notably, like there are some like issues with content security policy. Like one of them might be like if you're not preventing frame jack, or if you're not preventing click jacking, that could lead to just issues all across the board. You could still kind of get some user interaction out of it. There's also a handful of other things you could do, like I know that there's some like hash collision type attacks that you can do with a content security policy, but that's kind of far out. The biggest ones are like, large applications aren't necessarily always going to use the script source self because they want to use third-party libraries. So, as a developer, you want to make sure that the libraries that you're using, you're keeping them up to date. You're not using ones that are, never kept up either, and that you're just keeping a close eye on all the scripts that you're using, and that you understand the security implications of those decisions. With that being said, and again, that was kind of a high-level overview, but we'll go ahead and jump into our one and only example here, Bankrobber, that I think is just pretty solid. And then we'll jump back here and talk about prevention. All right, so we're here and I've booted up the Bankrobber machine, and I've gone ahead and gone to the main page, I made an account, and you can see that the functionality, we've got like a balance here, and we can transfer coins to other users. What's interesting first, what I want to do, so let me just turn on my proxy, and we're just going to send something to 1.1 and say testing. We make sure that my intercept is on. Go ahead and transfer this. And the first interesting thing that we can see here, right, is we can see our own ID number. We can see our username, which is just URL encoded, or my bad, it's URL encoded, then it's base64 encoded. So you apply those two things, and then you can see my username, and the same goes for the password, right? So you could already make an argument like this is kind of bad because it's being transported over HTTP. How secure is that? Not really what we're going to be going over here, but definitely worth looking at. Anyway, but the interesting thing is, I'll send this. It gives me an OK message, and you won't see this in the browser, but here you see there's a dialog window that's like, or let me actually go ahead and forward this request. Transfer on hold. An admin will review it within a minute. This is kind of CTF-y. An admin will review this within 1 minute. That's not true, by the way. This box has like a 5-minute buffer, but whatever. After that, they decide whether or not the transaction will be dropped. So we know that, this data here is going to be accessed by some administrator user. And in our instance, like we can't really directly, test out certain things. I can try, putting like script alert. Let me get rid of that semicolon. And the thing is, like, it doesn't execute in our browser because, something just isn't happening here. I know that there's a way that you can, I don't know if it's later in the machine or during the machine here, that you can do like SQL injection. You can actually read the source and figure out exactly why. But there's another way that you can do it by just kind of guess and check. So what we're going to do is we're just going to open a Python listener and see if we can get this to call out to our domain. So I'm just going to do Python 3. Just going to open it on port 80. And then I'm just going to use let's try, if we know, let's just try, oh, come on. We'll do like source. What's my IP? 165? Okay. And let's just have it call out for test. Yeah, that's fine. And we can go ahead and transfer that. And the tricky thing, right, is that we kind of have to wait for this to come back, which is tedious for the sake of this machine, but like I get it, like that's how they're going to implement it. So I might do a jump cut in the video, I might not. Just kind of depends on what's going on here with how long it ends up making us wait. In my experience, it's usually not longer than a couple minutes, but you never really know. So I guess we'll sit and wait for something to happen, and then we should see a GET request come through at some point. All right, so you can see that it did try to request that test document. And the reason this is nice is because already this is an example. Okay, it executed that JavaScript, which, you've already claimed. And you could have verified that in a variety of different ways, but this is like the most straightforward, at least in my opinion. Now we just want to try and get it to send us some kind of data that could be useful. And obviously, like, we already know some data that's useful, right? We know that in the request, and we know that an admin is viewing this, which is where that traffic comes from. So we know that there's a username and password parameter that we can use. So I've already got one pulled up here, but actually, let me, yeah, we'll just do this. Nano, I think it's, yeah. Oh, is that empty? No way. Okay, it's called cookie. Oh, you can see the other times we tried to do it coming through. So I just made this request that will, basically, it makes a new request. It tries to, or how do I describe it? So the administrator is going to click, he's going to go view our request, and he's going to, when he views the request, the JavaScript is going to call out to our machine, or we're going to have our payload call out to this JavaScript, and it's going to execute it, and then it's going to send us his, document cookie data to our web server, just in the URL. So all I've got to do for that is make sure we've got our server listening on port 80, and then we're just going to have to modify our payload a little bit, really not much. Instead of having it reach out to test, we're just going to reach out to cookie.js. Whoops, that was a comma. And let me just double check. Syntax is fine. Okay. We'll go ahead and run this transfer, and then we'll give it a minute. Might not take that long. Might take 5 minutes. Might take 2 minutes. We'll find out. But what we're expecting is we send this to the administrator. The administrator views it. It executes first this script, which it's just saying, the script source is found here. So it'll execute the JavaScript that we're hosting instead of us having to put all that logic in here, which I don't think we'd really be able to because it might be too long, or it might run into a blacklisted character. But it'll execute the JavaScript that we're hosting after it gets that file. And in doing so, it should send us the, at least the username and password information that's there. Or I think document.cookie, we might be able to see that. Yeah, it's the same kind of thing from here. So it's going to grab this information, and then it should just send it to us in that URL parameter. So we'll go ahead and look at our terminal, and we'll just start waiting. All right, so we gave it a couple minutes, and you can see that, it got our cookie.js, gave us the status code 200, and then it executed that correctly by showing us, the username and password content. So if we want to, I'll just use the burp decoder for all this. Let me just grab everything it returned here. Whoops, Control-Shift-C. We'll go ahead and just bring it to the decoder. And I think it was first URL, and then it was base64. Yeah, so now we got an admin username and their password. So we can move on to the next part of the machine. So let me just go ahead and, we might want to keep that open. We might not. Let me just double check and think about it here. Whatever. We'll log out. We'll see what happens. So we can just do admin, paste his password, and you'll notice, right, we've got, you can even see how you can accept and reject requests. I'll go ahead and, let me open my listener again. I'll accept this request. I don't think it actually works most of the time, at least when I was testing this earlier. This like accept button doesn't really work. It just kind of shows you the queue. It doesn't actually, do what we want it to. But there's some interesting functionalities here. You can search through users. There's a security feature that's just this thing called backdoor checker. And, you can see for safety users, we can only run the dir command without any arguments. If we try to run the dir command, though, it looks like we can only access this from localhost due to recent hack attempts, which is kind of weird word choice, but I'm not a linguist or an English professor, so I'm not going to talk about it. But what I do think interesting is that they're saying, only from localhost. For CTFs, at least, this should be screaming at you that you should be looking for some cross-site request forgery, or at the very least, you should try to pretend like you're localhost. And there's various ways we can do this, but, thinking about it, right, we can already get something requested from the right, this request is already coming from the target server. So the administrator, at least, in this case, is an automated task probably that's just going in and accepting requests over and over again. So we already know that we can request something using our JavaScript on the behalf of the administrator user. And we can just kind of rinse and repeat and do the exact same thing. I've already got this drafted up, but what we want to do is, maybe get a reverse shell out of this. So in this other tab, or actually I'll just show you here. So we'll just do, I think I called the file backdoor. You can't really read it like that. Let me just go ahead and open it in like mousepad here. Can't really zoom in here, so you're kind of stuck with this view, but same thing. We create an HTTP request. This time it's going to be a post request to backdoor checker. And these things, I'll actually just show you here. So we'll go ahead and just capture a request to this. And let me just go to proxy. Okay, my intercept is on. And I'm just copying, it's a post request. Here's our content type. I think this is the only thing that's really required. There might be, yeah, that's really the only thing it begs for. And, because this JavaScript is going to be executed and sent from, the machine that it's being hosted on, it's not going to be an issue. And then we're just going to have it send this data. The reason this doesn't work from us is because, we can't, CMD, which is the parameter down here, it doesn't work coming from us. If I were to do like ls, we can't do anything unless we are localhost, period. So you have to do something like this. I have this written out to give us a reverse shell just for the proof of concept. You could slowly migrate it out by having it send you an HTTP request, or send you an HTTP request similar to how we leaked the document.cookie, where you have it list the file contents or something, or run some other command like a ns lookup on your domain or something. So there's other examples, but this is what we're going to be doing. So we're just going to invoke a web request to our domain here, and it's going to grab netcat.exe, which I've got in this directory that we're hosting in. It's just going to write it out to the temp directory, and then it's going to run that and then send us a reverse shell on port, or at least not a reverse shell, but it's going to send us a command, a CMD instance to our IP address at this port. So without any further ado, let's just go ahead and we've already got our HTTP server running. Let me just do netcat listening verbose on port 1337. And then we will go ahead and get this payload together. I'm going to, let me see, transactions. I think I'll have to log out and log back in for this, but that's fine. Oh, I still got my proxy on, no wonder. All right, we'll log out, we'll log back in. And we'll just do like script. I think we had source last time. Oh, I kind of wish I left that window open. What is it, 165? Okay. And then we want it to get backdoor.js. I think that's all we want it to do. Yeah, it should be okay. I'm just canceling out that script tab. I can transfer the eCoin. And just like the last couple attacks, right? Now we can just kind of hang out and wait until that gets exploited. So hopefully it doesn't take that long. Either way, I'll be back in a couple minutes. All right, a quick edit. Found out that there was a typo here because when this came through, it returned a 404 because it URL encoded that other dot there. So I fixed it, running it again. Should see better results on the second time through. So I'll be back when that works out. Okay, so after, you can probably see the timestamps there. It took me a little bit. Eventually got it. So the administrator went ahead and looked at our page and accepted the request. The JavaScript executed in his browser, and it executed the JavaScript that we have in backdoor.js, which in turn grabbed netcat and then sent us a shell as a user. So, in this case, we were able to use cross-site scripting in combination with server-side request forgery to get a shell on a web application or on a, machine that's hosting a web application. So just something to keep in mind, a cool example, but we'll go ahead and wrap things up again with prevention, and then we'll send you on your way. All right. So there's a bunch of general principles that we want to use when preventing cross-site scripting, but a lot of these are pretty straightforward. So encoding output, when, some kind of user controllable data is being passed and written on the page, go ahead and encode it. This is going to make it a lot more difficult for attackers to not only verify that their scripts are working, but verify why they aren't working. And, it's just going to make your site much less of a low-hanging fruit than it might be with no kind of encoding. Next, you're also going to want to be validating input. So, if you have a comment section, right, like, users don't need to be putting in all these different characters. They don't need to be putting, tag characters. They don't need to be using all this stuff. And so you can just whitelist the characters you want people to use, right? It's not super complicated. And yeah, there's ways people can get around it sometimes. And you just got to be vigilant about how you're encoding and decoding things and how you're validating. But it's definitely better than having nothing. Safe HTML is basically just keep an eye on the dependencies and third-party stuff that you're, JavaScript that you're using on your site. Make sure that the way you're encoding stuff and the way that your libraries are, encoding, decoding, and validating input, if you're not using your own, are securely implemented. And, go ahead and ask other people with more experience to take a look at it for you if you are doing all this stuff yourself, because it's hard to get a lot of these security things right, especially on the first try when you don't really know what to look for or what, a secure version of the program might be. And finally, utilize a content security policy. It's a pretty straightforward way to do it. You just set up that header and you're pretty much good to go. It's one of the more robust ways of dealing with cross-site scripting, given it's designed to deal with cross-site scripting attacks. It's a designed countermeasure, and it works pretty well. So, strongly recommend. But that's all we've got for today. I'll go ahead and catch you guys in the next video, which should be about cross-origin resource sharing, which will be a lot of fun. But until then, I'll see you.